Well, alrighty. This is properties of rational expressions. So let's start off by just saying, what do we mean by rational expressions? Well, for lack of a better word, they're kind of fractions. Okay, so when we say rational expressions, we're really talking about fractions. And we're not just talking about any fractions, we're talking about fractions that have some kind of polynomial on top and a polynomial on the bottom. So let me give you just a couple examples here. So we might just have a 2 on top and maybe an x squared on the bottom, something like that. Or maybe we have a little more on the top. Maybe we have x plus 3, and maybe on the bottom we have x squared minus 6x or something like that, okay? What we don't want to see is things like if you had, say, 2 on the top and then someone tries to put in a square root of x, okay? That's no good. This is not a rational expression, and the reason is because you got the square root of x, which isn't really a true polynomial. So we're not going to run into these kinds of strange things where you have strange square roots or cube roots or some other kind of weird function of x. It's kind of the predictable functions where you have things like x squareds and x's and maybe some numbers. That kind of stuff is what we expect to see. So what we're going to do is let's look at some of these things. Like here's a nice simple rational expression. And the big thing we're going to talk about are restrictions. Okay, so what do we mean by restrictions? Okay, well, when you're dealing with fractions, things like this, 2 divided by 4, that's okay, because that's just like 1 over 2 or something. That's all right. But what if you tried to do 2 over 0? Oops, can't do that. Anytime you try to put a 0 on the bottom, this is bad, okay? We don't care about 0 on the top. 0 divided by 2 is okay. Actually, that would equal 0. But if you tried it on your calculator, you could try 2 divided by 0, and you'll see it says error. It just doesn't work. So when we're talking about restrictions, when we look at something like 1 over x, the restrictions would be, I better not ever let x equal 0. So I have this x not allowed or not equal to 0. And that tells me any other number on the bottom would be fine. So let's look at a couple more examples like that. Say I had x plus 2 on the top, and maybe I had x minus 3 on the bottom. And all I want to try and do is identify restrictions. Okay, what can x equal? Well, here's the thing. All you really care about is the denominator. So you don't care what happens on the top. You know, negative 2 is okay because negative 2 plus 2 makes 0 on the top, but it doesn't make 0 on the bottom. So the only bad number here is 3. Because the 3 plugged in for x would produce a 0 on the bottom, and that's considered a no-no. All right, what if we do, let's squeeze one more in here. How about x on the top and x squared minus 9? Okay, here's an example where there's more than one restriction. X is not allowed to be either positive or negative 3. Okay, because any of those choices, when you square them, you get 9, and 9 minus 9 is 0. So those are all kind of bad. So that's what we mean by restrictions. When you look at these rational expressions, you look at the denominators, and you don't want the denominator to turn to 0. So these are the places that x should not be allowed to equal. Now let me just clear the screen and show you sometimes you get something, say like this, I don't know, x plus 7. Maybe on the bottom you have something like x squared plus 1. Well, here's the scoop. You look at restrictions and you go, okay, what's going to cause me a 0 in the denominator? So I'm looking at this here and I go, okay, what would happen here? What number might turn this thing into a 0? Well, the answer is there is no such x. Okay, this thing is always going to be more than 0. It's always 1 or more. Okay, no matter what number I try to stuff in here for x. If I tried to stuff in, say, -1, well, it would get squared, be positive 1 plus 1, so that's going to be a 2. If I tried to plug in a 0, 0 squared plus 1, well, that's going to be 1. In fact, you're never going to get a number smaller than 1. So restrictions, there are none. Okay? All right, so all kinds of stuff can happen, all kinds of stuff. All right, next thing I'm going to do here is I want to look at simplifying these things. So I'm going to clear the screen here, and we're going to look at kind of the big picture. Like, say you had just some numbers here, okay, 10 over 15. Well, I could simplify that because I could go, oh, 10 and 15 are both divisible by 5. So this would simplify down to 2/3. Okay, nothing new there. But let me just make something really, really clear. Suppose I rewrote that 10 as 2 times 5, and I rewrote the 15 as 3 times 5. Okay, we use a little trick sometimes when things are multiplied together across the top and things are multiplied together across the bottom, where we go, oh, look, a 5 and a 5. We're going to cancel those, so this becomes 2/3. Now, when we do this canceling, what we're actually doing is we're going 5 divided by 5 becomes a 1. 5 on the bottom divided by 5 becomes a 1. So technically, it doesn't actually just disappear, but it becomes a 1. So this is okay. We're allowed to do this. But be careful, because if you had something like this, I'm going to take the 10, and I'm going to write it as 5 plus 5. And on the bottom, I'm going to write that 15 as, say, 5 plus 10. A lot of students, they look at this and they want to cancel these 5s, okay? But you can't do that. And here's the reason why you can't. It's because that's a plus, okay? You're not multiplying these things together. Same thing down here, okay? So you can't just go ahead and go, oh, look, I'm going to cancel this 5 here with this 5. Not allowed to. It gives you a wrong answer. Okay? So just be clear that when things are multiplied together, it's good and we can do it. But when things are added or subtracted, then you can't do this canceling trick. Okay? It doesn't work. All right, keeping that in mind, I'm now going to look at some examples. Maybe we'll just do one example, and then I'll come back with another example. So we don't want to keep you too long here. So we'll just do one example, and then we'll come back later. Okay, in this example, we're going to take 5x minus 10. And we're going to divide all that by 7x minus 14. Now, we want to try to simplify this, but we have terms here that are not multiplied together. So what should we do? Well, here's kind of step 1 in all this stuff. If you can factor, that's what you should do. So you factor the top, you factor the bottom. So if I look at the top of this thing, I can take out a common factor of 5. So that would leave me with x minus 2. And on the bottom, I'm going to take out a common factor of 7, and that also leaves me with x minus 2. Well, what you have now technically looks like this. We have 5 times this little bundle, and on the bottom we have 7 times the same little bundle. And because we're multiplying things together on the top, things together on the bottom, these bundles can be canceled. In other words, I can do this. Just cancel off the whole bundle. So my answer is 5 over 7. 5 sevenths. And I'm going to throw in one little restriction here. Okay, there's one thing about x. X cannot equal 2. Because if x equals 2, you're making a 0 on the bottom. And that's considered bad. Okay, I think that's where I'm going to stop. And we'll continue in a little while.